All right, so this is the second part of this. So now let's look. We know that the periodic table is made of periods and groups. So remember, periods are the rows. Periods are the rows on the periodic table. And groups are the columns. Okay, and remember that the rows, there are 7 of them, 7 rows, and they have electron shells. So row 1 has orbital 1, row 2 has 2 orbitals, row 3 has 3 orbitals, and so forth. And the groups have the number of electrons in the outer shell. So let's take a look at this a little bit differently. Each element has its own chemical symbol. This is the chemical symbol. So the name xenon has a chemical symbol X, capital X, and little e. So if it has 2 letters, it's always first capital, the second one is lowercase. Okay. There is important information about this. So this, the 54, tells us the number of protons in the element in the nucleus. So this has quite a few. And also in the nucleus, it has neutrons. So this number, 131, we'll round that up, is really equal to the protons plus the neutrons. Okay? Protons and neutrons. So if there are 54, this one has 54 protons plus the number of neutrons that equal 131. So let's take a look at another element, carbon. Protons. In the nucleus, there are 6. We're going to round this to 12. This has 6 protons plus the number of neutrons equals 12. So in this particular case, in the nucleus, there are 6 plus 6 neutrons equals 12. A lot of times, the number of neutrons is equal to the number of protons. So this is 6 and 6. So this is what this information is telling us here. Neon, the atomic symbol or abbreviation for the element's name. Some are harder than others. They figure out because they use a Latin name. So neon, Ne, number of protons in the nucleus. So if I'm drawing this in here, so let's say this is the nucleus. This has 10p protons. Okay, we're going to round this to 20. Remember, this is 20 protons plus, I'm sorry, let's do that over again. This is 10 protons plus 10 neutrons equal 20. Right, so in the nucleus, there are 10 protons and 10 neutrons. And the neutrons hold the protons together. So the 10 protons there, and the 20 represents the total. The atomic mass tells you how much the atom weighs. So this is the atomic mass. And remember, the atomic mass is 20 protons from here, plus whatever makes this make up to 40. So 20 neutrons. So we're rounding this to 40. So 20 protons plus 20 neutrons. And those are in the nucleus. Remember, this is the nucleus. 20 protons, 20 neutrons. So who put this information together in the table? All right, well, we're going to talk about that today. So Dmitry Mendeleev, in 1869, he arranged the elements known at the time into a table. Although it has expanded over the time, the same basic principles are used today. Let's look at some work that we can learn from the periodic table. There are three main types of elements in the periodic table. So in the pink are the metals. So you can see that hydrogen is not a metal, but all these right here are metals. Okay, so that's the majority. Most of the elements are metals. The metalloids are the stair step in green, right? And the nonmetals are in blue. So on the right side are the nonmetals. On the left side are the metals. And kind of in between are the metalloids. The metals have similar properties. They're usually solid, shiny, and good conductors of electricity and heat. So your pots and pans are made out of those, So if you got a pan on the heat, right, they work the best for cooking food. And that means they conduct heat well. So if you have the flame underneath, it doesn't take long for it to heat up. Metals are also ductile, which means that they can be pulled into wires. Metals can be malleable, which means they can be hammered into sheets. And some sheets, like aluminum foil, are very thin. And they are very thin sheets, so they can be hammered and stretched. Non-metals are just the opposite of metals. So here's a picture of sulfur. Looks like crumbles. They are not ductile, meaning they can't be stretched into wires, not wires, can't be stretched or smashed into sheets. Can't be smashed into sheets. Non-metals are not very good conductors. So non-metals are not very good conductors. Often they're used as insulators. So here is an electric fence. And this is the insulator here that keeps the electricity from flowing into the post. And again, if you have a a metal pan, you might want to have the handle of this metal pot or pan be an insulator because you have to pick it up. So the metal pan or pot you add water to, but you want this handle to be an insulator. So you might want to use it as a non-metal. So that means the metalloids is somewhere in between. So somewhere between metal and non-metal are the metalloids. Metalloids tend to be partially conductive, so they're valuable in creating computers. So this is a chip, computer chip. Metalloids are solid or liquid. They usually are not and usually are ductile and malleable, Lastly, let's look at a couple cool things about the periodic table. The far right of the table contains noble gases. And noble means like rulers, people that were kings and queens. And the reason they say that is because these don't want to associate with anybody else. So kings stay with kings, queens with queens. They don't want to mix with others here. Noble gases are the most stable of all elements, and the outer shell is completely full of electrons. So being completely full is a great thing. At the top of the table, there are two special elements, hydrogen and helium. Hydrogen is the only element without a neutron. That's kind of interesting. So there's only just one proton in there. It's the most common in the universe. Helium is grouped in with the noble gases. It only has 2 electrons in the outer shell, but is incredibly stable. So there's most of them after helium, the noble gases have 8. So they want to get to 8. There is a lot of information packed in the periodic table. Each element has its own properties and unique characteristics. So we're going to stop there.